are back, and we are potentially better than ever. I don't really know. I haven't really. It's not something I can measure. I haven't done one of these in 6 months. Well, at least that's what YouTube says. And I really wanted to do one, and I was like, you know what? If I'm gonna do it, why does he just film it? You know. Also change the theme. I don't know how I feel about it. I'm not sure if I like it more, but whatever. I think we're up to number 7. A sanger Sudoku sandwich. I've never known how to pronounce that word. Okay. Classic rules and a sandwich sanger rule. The numbers outside each row and column correspond to the sum of the numbers between 1 and 9 in that row or column. Okay, so let's take this 3 for example. Let's say this is a 9. So between the 9 and the 1 in this column, well, let me just get the rules back up. Between the 9 and the 1 in this column, it must sum to the digit outside. So it must sum between. So let's say the one's here. The numbers in between the 9 and 1 have to sum to 3, which is only going to be 3 there. Right, okay. That makes sense. Let's say for 14, let's say we had a 9 here and a 1 here. What can go in here that makes 14? What, a 6? A 6. No, it's not a 6. A 6 and an 8. So the numbers in between the 1 and the 9 in that row sum to the digits outside. Okay. So let's get started. Also, that's why these things go. The combinations, which will help me out quite a bit as I can see what combinations can be in between the 1 and the 9. But these 32 and 33 do interest me immediately, as they both only have one way you can get the numbers in between the 1 and the 9 to sum to 32. Obviously you can't use the 1 and the 9, otherwise they'll break normal Sudoku rules. So, given that there's 6 numbers in between the 1 and the 9, let's say I have 1's here, there would be 1, 2, 3, 4, 5, 6. And I guess that's the same the other way. So these 4 numbers must be in between, which means the 1 and the 9 either have to be here or here. And I'm assuming this pattern will work for the 33. Yeah, 6 numbers, so let's say that's going to be orange, these 2. And then let's just put this as green. So if that's a 1 or a 9, that's the other. So if that's a 1, that's a 9. If that's a 9, that's a 1. Okay. Okay, these 2's and 3's are interesting now. Because obviously if that's a 9 or a 1, that would have to also be a 9 or a 1. Because then, otherwise, because we have to fit 2 in between the 9 and 1, which can only be obviously a 1 cell. So that would have to be a 2. Guess that's the same for this orange here as well then, with the 3. Is that the same for the pink? Yes, if that's a 1 or a 9, then the other 1 or a 9 has to be there. And it can't, and that would have to be a 2 in there. So it's the same for pink, and I'm assuming the same for blue. Okay, but if, let's say pink's a 1 or a 9 then, that means that green also can't be 1 or a 9. So which means pink and orange, so it's either pink and orange, or blue and green. Because obviously you can't have pink and green, or blue and orange. Whoa, so it's pink and orange. So let's color let's color these. I like pink. Let's color these pink. And let's color these blue. Okay, so it's either there and there. There and okay. So it's either the pinks are the ones in the 9s or the blues are the ones in the 9s. But we don't know which one yet. Okay, so the numbers in between the 1 and the 9 have to be 3, 4, 5, 6, 7 or 8, which means if this was blue, a 1 and 9, that would be the numbers from 1 to 9 excluding 2, so that would be a 2. And that's the same for if it was pink, so those would be the numbers 1 through 9 excluding 2. And for this, that would be the same but excluding 3. Because 3 is not in this thing up here on the combinations. Now, this 2, let's say we do the blue pair, right? That, oh, I broke my control key. Look at this thing. Oops. Some would say I've lost control. No, I haven't lost it. I've just broken the control. Okay, we're back. Where was I? Blue. Yeah, okay, so if blues were the ones in the 9s, that would put a 2 there, but since that's a 1 or a 9, the other 1 or 9 has to go here, and then a 2 has to go in here to satisfy this Sudoku rule, which means blue cannot be a 1 or a 9, which means that we are looking at pinks being our 1s and 9s, which means in between this 1 and 9 is a 3, and in between this 1 and 9 is a 2, which means that's a 3 and that's a 2 through this one. Okay, hopefully that all makes sense. It makes sense in my mind, at least. That's obviously pink now. And then where to? Okay, let's see this 14. Okay, I'm going to come to the conclusion that it's not got 3 digits in between it. Because if it did, that means the 1 and the 9 would have to be here, and there's no way, if this is a 1 or a 9, you can fit digits that sum to 14 in between these two. So that is not a 1 or a 9, which means the 1 or a 9 is either there or there, which means we can either have 2 digits in between or 4, which means it's not this, it's not this, not this, not this. Okay. What other? Okay, we have got a cell for these 1s and 9s with a 14. But then we also have this 14. And obviously this 14, the other 1 and 9 would have to be here somewhere. And this one, the other one would have to be here somewhere at the top. So let's say this is 3. So this is 2, 4, 8 for example. That means that would be a 1 or a 9. That's obviously a 9 now because the 1's in the box. And then this partner can't be there, so it'd have to be here. And it'd have to be 4, so it'd be a 2, 3, 4, 5. That's the same thing if this was here. Yeah, because you can only have 2 pinks in a box. Right, so we know that one of them has to finish outside the box. We don't know which one yet, do we? Let's look at this 20 now. Because we have a potential number here. Let's say this is a 1 or a 9. We need at least 3 in between. Which would mean that we'd have to at least get these 3 lower. And then we can't go there, because then they'd be in this row. and then it would have to go there. So that would be our thing with 4 in between, which annoyingly has all the options. Okay, the 12, does that get us anywhere? 12 either has to have 2. So if it goes up, it has to have 2 in it, and if it goes down, also has to have 2 in it. So if this is a 1 or a 9, it has to be 2. Okay. We seem to be making a little progress, which is okay. It's 14. It's got to be these 14s in this middle box somehow, surely. Maybe it's 2s and 3s. We know it's not the 5, that's what we know for certain here. And we also know it's not the 3, with this 20. Yeah, what do we do next? Okay, so what is the 1 and the 9 gun in this box is what I'm starting to figure out here. So it can't go there, otherwise this 14 ruins. Can't go there because of the 1 and the 9 in this column 2. Can't go there, obviously, because of the 1 and 9 in row 2. Can't go there because of 1 and 9 in column 2. Can't go there because of the 14. Can't go there because of the 1 and the 9 in row 2. So the 1 and the 9 has to either be at the top here or at the bottom. Basically what I'm doing with the grey, actually I'll colour these a different grey, means that well, one of them is, and they're a pair, so this one is, this one isn't. Okay, so let's see what this makes this 12. We go either there or there. Which, whoa, so it can't be there and there, because then that's obviously not going to make 12. This has got me stumped. Okay, maybe it's this 12 that's the solution. Well, it can't be 3 up, so it has to be 2, if it is this. Or 2 down. No, this is not going anywhere. Ah, there we go. This is how I meant to do it. This obviously can't be a 4, because it would have to be 2, 3, 4, 5, and we've already got a 3 in the row. So this is the 2, with that being a 1 and a 9, with this now being a 6, 8 pair. How fun. That changes 14. Okay, now this 14 can't be a 2, because obviously that would mean that a 6 or an 8 couldn't go there. So one of these is now a 1 or a 9. It's either one of these or one of these. Now if it's this, obviously we'll have both this, but if it's this, that means it's this. And if it's this, it's this. Okay. Okay, what next? Okay, well, let's check this with a 15. Nope. So it can be a 2 down, so it doesn't rule out anything, that's fair point. Actually, it can't be a 3 down. Okay. Okay, so that's a 9. Sudoku. That's a 1. Wow, I'm that bad at Sudoku, really? That's a 1, that's a 9, that's a 1. Oh, okay, so now we get 1s like this and like this. So the 1, the 9 has to go here. Color it with the black one. So can it be the... Because obviously in this column it can't be the two outside ones. But can it be, let's say, this outside one and this inside one, which means there's a gap of 5? No. 2. But it can be 2 though. So we can't rule out anything because it could be there and there. No, it can't be because we need a 1 down here. So this can't be a 1 or a 9. Friends, in this box, that has to be the 9. I hope you guys followed. I hope we followed that. Because there has to be a 1 here. The maximum the 9 can be is 1, 2, 3, 4, 5. So in this cell here. I don't like how it highlights with this thing. You can see that. Let me just... this cell. Which means that this can't possibly be included. And given that that's the only other place the 9 could have gone in this box. That's a 9. And that's not a 9 now. Because that's the 1 that wouldn't sum. Can it be 5 away? No, it cannot. Because we can't get 5 numbers to sum to 15. No, 5 numbers to sum to 20 with Sudoku rules here. Without using 9. So that can't be it by the same method. So it's just kind of like solved itself. That's kind of handy. That's a 1. Oh, I was looking at the 15. Hey, just take back everything I said, you know. So these can all still be pink. I love this game. Okay, let's try to do this again. Why did we say it can't be the 5? Well, it can be. Why are we saying it can't be 5? Why are we saying it can't be 3? Why have I crossed those two out? It's because that can't be a 1 or a 9 now because it's in the same box. Oh my god. Oh my lord. But this could also be a 2. Oh no, it can't be a 2. Which we established because it's 6 and 8. So that is a 1 or a 9. And since it's in that box, it's a 9. And that would make that 9 as well. Whoa. You know, when you use your brain, you can actually solve things. It's crazy. It actually never occurred to me before. Okay, so that means this, if it's the 14, has to be the 2, the 3, the 4, and the 5. Which means this thing must have at least a 2, a 3, or 4, or 5, which they all do. Okay, let's say this is a 1 down here, this column 3, row 9. And the only, that has to be a 1, right? The only other place, let's just think like these two squares and these two squares and their relation. Let's call them green. Because one of these has to be a 9, right? Let's say this is the 9, this can't be a 1. And if this is the 9, this can't be a 1, because obviously... That's right, if this is a 9, this could still be a 1. But if this is a 9, this can't be a 1. Because the 1 would have to go here or here. Okay, I don't think I can actually get anywhere with that. Okay, this 14 now intrigues me, so it can't be the 4. because it shares similar numbers with the 2, 3, 4, and 5. Let's say I put a 2 here. That means 3, 4, and 5 are going to have to be in here. But if I put like a 4 here, that means 2, 3, 5 have to be here. Which means I could put a 2 here and still have 3 and 5 in here. Right, okay. Actually, maybe. No, that doesn't help me at all. Let's look at this 15 now. Okay, that can't be. So I've just established it can't be the 7 and an 8. Because that means it would have to be 2 gap, which would put 1 there, a 1 there. Yep, and this has to be a 2, 3, 4, or 5. To make 2 it would have to be a 7 or 8. And to go up 2, that would have to be a 1. Which means to make this 12, we would have to put the 9 either here or here, which both don't work because it's Sudoku. So this 15 cannot be a 7 or an 8. Which means it cannot go up. And it can't be a 3 because those numbers, you know what I mean? No, because then the 1 would have to be here and that clashes. So that has to be a 1. Which means this can no longer be a 1, and that puts us a 1 in here. And this is now a 2, 3, 4, 6 quadruplet. But this obviously cannot be 6. Well, now it can't be 5 because this has to be in this and in this. Okay, well that can't be a 2 and that can't be a 3. But basic Sudoku. Okay, this has helped us here. 3, 4, 5. Let's look at this 20 now. So we could probably do this 12 actually, which is helpful. So if it can't be 3 because I would put a 1 there, which doesn't work with row 2. So it has to be 2. That was easy. Hope it's right though. And I think we have, how many ones do we have? 1, 2, 3, 4, 5, 6, 7, 8, which means we can place the last one by a normal Sudoku up there. Which means that's the 9 to make this 12 work. Okay, this is starting to work out. Which means this 20 has 5 digits, which means it's a 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Which means the numbers not included in that row are 7 and 8. And this 12 either has to be a 4 and 8 or a 5 and a 7. And given that this cannot be an 8. Okay, that doesn't help us. Okay, that can't be a 2. And that can't be a 3. Once again, normal Sudoku. This 12. Okay, either has to be a 4 and an 8 or a 5 and a 7. But we know there's a 4 in one of these 4 cells. But we know nothing about the 5, the 7, or the 8. That we know that the 5, the 7, and 8 go to those 3 cells. Okay. This box is looking decently done. 6 can't go there because there's a 6 guaranteed there, which means it goes there, and the last 2 are 4 and 5. Okay, then we get another pair up here, which has to be a 2, or a 7, I believe. Ooh. That means if there's a 7 there, this has to be for an 8-4. Oh. We need high numbers. Wow, okay, so 7. So we know this has got 3 now, right? So the numbers 7 and 8 have to go into these 3 cells. Which means, well, can we get 7 and 8 in those 2? No. Which means this has to be either a 7 or an 8. There has to be a 7 or 8 in here, which means it can't be 3, 5, 6. Given that there is only one 7, 8 in here, that means both of these 2 have to be either be a 2, a 3, or a 4, or 5. 2, 3, 4, 5. And we can only have a 4 and a 5, so anything here that doesn't have a 4 or 5 in it is automatically cooked, because this can't be a 7 or an 8. 8 or... no, it can't be. Because then this is 7 and 8. One of these has to be a 7 and 8, and that obviously adds up to more than 14. So this is either a 7 or an 8, which means this is a 4 or a 5 to make this 12 work, and this 14. Okay, they both all got 4s or 5s, so I thought I was cooking. But evidently I am not. Ooh. So we've got like a weird quintuplet, a 5 or whatever with this here as well. That's a quartet. That's another quartet. That's a quintet. I'll go with quintet. Why not? Let's see. I don't think I've placed all the 9s, have I? I should be able to. That has to be a 9. Or that can be a 9. One of those is a 9. Ah, there's 17. Okay, surely. The 9 has to go in the corner in this bottom row. It has to have 4 in between, okay. It can't have both 4 or 5, or it can't have both 7 and 8. So it can't be that one. Which means it has a 2 and a 3. Then either 4 and 8 or 5 and 7. This is so confusing, man. And if I'm confused... Seven, 8 here. I want to simplify this down somehow. So whatever number goes here has to go here or in here. Ah, okay. So given that the 4 or 5 is out here, the 2 or the 3 must be in here. So we know there's either a 2 or a 3 here. Which means whichever one's here has to go here. So whatever, whether it's a 2 or 3 that's here, let's say it's a 2 here, a 2 has to also go here. And then a 2 also has to go here. But if it's a 3 in here, the 3 has to go there by the same logic that 2 does. And then 3 has to go there. The 6? Ah! So this 14 can't have a 6 in it. So where else in this box does the 6 go? Has to go there. Oh my lordy lord. But can this be also, can this be both 2 and 3? So, because obviously 3, 2... which one's the 3 and 2 would have to go here? 2, 3. No, 3, 2. And 7, 8. In here. We know one of these is at least a 2 or a 3. We know there's a 7 and 8 or 8, not and, or 8 here. And a 2 or 3. This row needs a 6 and an 8 in it. Okay, so this has to be 6, 8 pair. Because 6 or 8 cannot go anywhere else in the row. Which means since there's 8 here, that's no longer possible to be an 8. So that's a 7. And to make this equal 12, we need a 5. 5. Which means this 14 now has to be a 2 and a 7. What do we say? When there's a 2 here, the 2 also has to be here to make this 14 work. Because it has to be a 2 somewhere here, can't be in here as it's in the same box, that's a 2. We said once that's a 2 now. To make this work. That 2's obviously made that a 7. Puts a 2 up the top up here. Whee! I feel like I'm cooking. Don't know what yet. I could go for a suv right now. You know, like a 11 o'clock suv. Ooh. Now. What do I do now? What's the other number in this row? We've got 1, we need 2 somewhere. Can't go there, obviously. Can't go there, obviously. Bang! Because the 2 in this row can't go there because it's in the same box. And there's, there's also a 2 there. Can't go there because there's 2, so that's a 2 now. Which means this is a 3, 4, 5 pair, not triple. Across this row. But obviously can't be a 5. Which means we know there's a 5 there. Alright. That also means that's a 3, 4 pair to finish the rest of the row. Where does the other 6 and 8 go in this row? It has to go here. Actually, no, it doesn't. Because the 6 could go there and 8 could go there. Or the 6 could go there. Or the 8 could go... Yeah, okay, that doesn't work. Um, I filled out all the 9s, right? No, I can still place T9 somewhere, either there or there. And neither of them have a sandwich clue that helps me place them, which is extremely annoying. Wait. The 6, the 8, and either a 3 or a 4 has to go here. The 6 can't go there. So this is either an 8, a 3, or a 4. Beautiful deduction. So we know there's a 5 here. Okay, it can still be an 8. Okay. 3, 4, 5, 6. A 7 has to just go in there, like... Okay. Okay, well that's obviously 5 and 7. Don't know what to do now. I went to the gym. Like, actually went to the gym. For the first time. I would say almost ever. Whether you can believe that or not. Definitely probably the first time I've actually gone to the gym. For going to the gym, rather than being like, you know, wash out for tennis or whatever. Just now my whole body's sore. And I'm having the time of my life. Okay, this 2, 3, 5, 7's looking very skeptical, to say the least. Because if this is a 2, 3, 5, 7 at the bottom, the 2 has to go there. Because it can't go there because of that 2. I'll be able to just solve some 2s. Which we can. Because we know this has to have a 2 in it. Right, and a 2 can't go there, 2 can't go there, 2 can't go there. So that is a 2. And then we have a 2's in here. Okay. The 3 now has to go here. This is so clever. Because it can't go here. And there's guaranteed a 3 in it. Since the 3 is here, that's a 4. This 4 makes this a 5, makes that a 4. Four, 8. I guess that works because that can be a 4, that can be an 8, that can be a 3. Yes. 5, 7 doesn't have any restrictions on it in here. But we know this. It can't be 4, 8 because now there's a 4 on the bottom left. Oh my lord. So this has to be a 5 or a 7. And this is now a 3, 5, 7. Triple across here. No, there's a 4 here now because of this row. This is so disgusting, all of this. We still don't have all the 9s. The 2s we established as this, the 3s. Can I do anything with them? no. This is basically the answer. Actually, no, I can, because this is technically a 3 here, and this is a 3 here. 3s are everywhere here. Which means that, those two, that can't, they all can't be 3s. That's a 3 right there. And then now this has to have 4, 6, and 8 in it. Okay. Well, that does not help me. I feel like I should be able to do more with this, you know. Oh, if only I could get like one of these digits. I probably could. Okay. Fours. This row, okay. These last 5 digits have to be a 3, a 4, a 5, a 6, and an 8. This is so annoying. Can I do this? No. No, I cannot. I am incapable. Ooh. That is probably the best solution to find out these 2 digits. Now, if you've already spotted this, good job. Come around to my house and I'll give you a pen. But if you haven't spotted it, I'll give you a little bit more. Very, very tricky. Very, very tricky. So obviously, these cells have to be either a 4 and an 8, or a 5 and a 7. So now we look at this box. So whatever 2 digits go here can't go here in this box, which means they would have to go here and here. Right? Basic Sudoku. But let's say this is a 5 and a 7. That means these 2 have to be a 5 and a 7. However, this cell cannot be a 5 or a 7. So that means these cells can't be 5 or a 7, which means these cells can't be a 5 or a 7. So these are 4 and 8 pairing. And the 4 can't go there, so that's an 8. And this is 4, 8 here. And now we know this is a 5, 7, 6 triple, which puts us a 3 in here. Finish out this row. So we know there's a 3 here, and an 8 here. Oh, this is just mind confugglement. Oh, this can't be a 4. Oh, it's solving itself. What a godsend. Yes, 'cause that can't be 3 or 4. The 4 here knocks that out to be a 4. This 5 obviously means this can't be a 5. This 7 obviously means that can't be a 7. So that's a 6 there. Okay, that has to be a 5 or a 7. Paste that. That's a pair now in that final row. That is now a 7 because of the 5 over here. 5 and 7. This has obviously made this not be able to be a 7, so that's a 5. And the last number in this row, no, column, is a 6. Which means this pairing is now a 8-9 pair. And that can't be an 8, so that's the 9. And that is the 8. And that 9 means that this other one is a 9, and this was a 2. We'll just colour these 9s real quick. So, and the 2. Well, there was something about a 2 being here or here, right? Yeah, so a 2 can't go anywhere there. Which that has to be a 2 right there. Which that's a 7. It's a 2. Oh, that 8 makes that a 6, and that an 8 which makes that a 4. 5 goes there, 3 goes there, 6, 5, 4, 3, 4. That must have just solved by me entering a few things. Same with this. Okay, this should just be solved, basically now. That is a 8. Which makes that a 7, and that an 8. These two digits are now 5 and a 6. So that's the 6 and that's the 5. Which makes that the 6. And that the 3. Okay, this has to be either a 7 or a 5. That can't be a 5, so that's the 7. That's the 5. That's a 7. And our last digit is an 8. Now, I hope this is right. Bang! Okay. 47 minutes. That's not bad. I'll take it. Once we got in a bit of a groove, and it kind of just worked out. Yep, that's it. That's how do I usually do these? Oh yeah, I might have already said this earlier, but turn those noties on. You know, you wouldn't want to miss this pure quality content. No, this content that I deliver, that I put my heart and soul and brain power into. Because I don't know, whenever I feel like I'll do these ones, I'll upload it. However, this next Sudoku, 500, what's that called? Exclamation mark, times 4, looks really, really interesting. There's a lot of rules going on, and I'm sure that will be extremely confusing, which is why it looks so fun. So I might be doing this soon, so you might get 2 within a week. I might be naughty like that. Anyway, nah, this was fun. How do I usually end these? I don't know how to